Welcome to the Explainer. Today, we're diving into something pretty cool, a tool that lets you stop disasters before they even begin.
Think about it. Product recalls, production lines grinding to a halt, major safety incidents, these things are nightmares for any company. We're talking huge costs, damaged reputations, the whole shebang. But what if there was a way to see these problems coming, to prevent them before they ever have a chance to happen?
Well, there is a way, and it's called FMEA, which stands for Failure Mode and Effects Analysis. The easiest way to think about it, it's like doing a pre-mortem on your project. Instead of asking what went wrong after a disaster, you get your team together beforehand and ask what could go wrong. It's an incredibly powerful way to get out in front of risk.
All right, so let's dig into why being proactive like this is such a game changer.
You know, FMEA isn't just some nice-to-have exercise. For a lot of companies, it's absolutely fundamental. I mean, first, it's all about proactive prevention, finding those ticking time bombs before they turn into expensive recalls. Second, in many industries like automotive, it's not even optional. It's required for compliance with major standards. And third, let's talk about the bottom line. It saves a ton of cash by cutting down on defects, scrap, and those dreaded warranty costs.
So how did we get this incredible tool, and more importantly, how does it actually work? Its history is pretty cool, actually.
This whole thing has a pretty amazing origin story. It actually started back in the 60s with NASA and the Apollo program. I mean, when you're sending people to the moon, failure's just not an option, right? Then the auto industry picked it up, but it kind of split. You had the American standard from a group called AIG, and a different, more structured one from the German auto industry, the VDA. For a long time, you had these two parallel tracks, but thankfully in 2019, they finally came together and harmonized the two into one unified global standard, which is what we use today.
So the modern process really boils down to 4 logical steps. It's pretty straightforward. First, you analyze. You have to really understand the system and everything it's supposed to do. Then you assess the risk. This is where you start putting some numbers on what could go wrong. After that, you prioritize. You can't fix everything at once, so you focus on the biggest, scariest threats first. And finally, you take action. You actually go and do something to lower that risk.
Okay, so let's get into the real heart of this thing. How do we actually measure risk? How do we put a number on it?
It all comes down to 3 key letters, S, O, and D. That stands for severity, occurrence, and detection. Let's break those down. First up is S for severity, and this one is 100% focused on the customer. If this failure happens, how bad is it for them? We rate it on a scale from 1 to 10. Is it just a little annoyance, or is it a catastrophic safety failure? That's severity. Next, we've got O for occurrence. Now, here's a really important point. We're not asking how often the failure happens. We're asking how likely is the root cause of that failure to happen. It's a subtle but crucial difference. And again, it's a simple 1 to 10 scale. And last but not least, D for detection. The question here is, how good are we at catching this problem before it gets to the customer? Do we have good checks in place? Now, you got to pay attention to this one because the scale is flipped. A low score is good, but a high score, a 10, is terrible. It means we have basically 0 chance of detecting the problem.
So you put these 3 numbers together, S, O, and D, and they tell you a story. Just look at this example. We've got a severity of 9. That's a critical, potentially dangerous problem. The occurrence is middle of the road, a 5. But look at the detection. It's an 8. That means we're really bad at finding it. A super severe problem that we can't detect, that's a huge flashing red light right there.
Okay, so we've got all these ratings, we've identified the red flags. How do we decide what to fix first? Let's talk about prioritizing action.
For a long time, the standard way to do this was to calculate something called a risk priority number, or RPN. The math was super simple. You just multiplied S times O times D.
Sounds easy, right? But there's a huge hidden flaw in this simple multiplication. Let me ask you this. Does an RPN of, say, 120 always mean the same thing?
Let's look at why not. Check out these 2 scenarios. In scenario A, you have a severity of 10. That's a critical safety issue. In scenario B, the severity is only a 6, maybe a performance issue. But because of how the other numbers work out, they both get an RPN of 120. But are they the same risk? No way. Scenario A is infinitely more important to fix right now, but the RPN number doesn't tell you that. And that is why the new, harmonized standard is so much better. It throws out the simple RPN and introduces something called the action priority table. Instead of a single misleading number, it uses a logic table to give you a clear, high, medium, or low priority for action. And here's the brilliant part. If your severity is a 9 or a 10, it is always a high priority. Period. It doesn't matter what the other two numbers are. This is a way smarter and, frankly, much safer way to prioritize.
Okay, so we know the theory, but knowing the process and actually making it work are two different things. Let's talk about how to make FMEA truly effective.
So what are the secrets to a successful FMEA? A few key things. Number 1, start early. The earlier you do it in the design process, the better. 2, get the right people in the room. You need a mix of folks from design, quality, manufacturing, everyone with a stake in the game. 3, focus on real, concrete actions. Don't just fill out a spreadsheet for the sake of it. And finally, remember this isn't a one-and-done thing. It's a living document. You have to keep it updated.
And just as important, here are the common traps people fall into. The biggest one, by far, is doing it too late. Another classic mistake is writing vague actions like monitor or improve. That's useless. Every action needs a specific owner and a hard deadline. And of course, like we just talked about, don't fall into the trap of only chasing the highest RPN scores and ignoring a critical safety issue.
But when you avoid those traps, when you do this right, the impact can be absolutely massive.
I mean, listen to this quote from a chief quality officer at a huge car company. They said that by systematically using FMEA, they cut their recalls by 60% and saved over 2 million euros every year, just in warranty costs. That's not small change. That is the real-world power of doing this right.
So that really just leaves one final thought for you. It doesn't matter if you're building a car, writing code, or designing a service. The question is the same. What hidden failures in your work are just sitting there, waiting to be found?